and good afternoon to all of you. Nice to see you with us. My name is David Levy Faur, and with me Dr. Nir Kosti. Nir is in Munich at the LMU. I am in Jerusalem, and with us today for the first time of the first event of this particular series, Xavier Fernández-i-Marín from the University of Barcelona and from eBay. I would say that this is the first of a series of webinars and actually a project on the metric of regulation. By metric of regulation, I mean, how do we quantify regulation? How do we do AI, artificial intelligence analysis better? And the basis is with better measures of regulation. Now, regulation is notorious for not being convenient to quantify. And when I say quantify, I mean the number of regulation, the number of laws, the number of words, but also the performance of regulation, public opinion on regulation, the text of regulation, how to do content analysis, and of course, with quantification not only coming AI, but also visualization. And on this topic, Xavier will present today. Nir will present Xavier, and then Xavier will start. Nir,
okay, thank you, David. So I will introduce our first speaker for this series. So we're happy to have here Xavier Fernández-i-Marín, a Ramon y Cajal Fellow at the University of Barcelona. Xavier develops and tailors solutions for social science research methods, including current developments in Bayesian inference, data visualization, probabilistic programming, experimental designs, and machine learning. Xavier's substantial contributions in comparative politics, public administration, public policy, international relations, and psychology. Xavier have worked in the field of global governance and international organizations, the diffusion of policies and institutions, and the processes of development of regulatory agencies. He works also on internet and e-government diffusion and other related aspects of the public management of the information society, which lately include the adoption of artificial intelligence in public administration. So, Xavier, the floor is yours.
Thank you very much, Nir. Thank you very much, David, for this nice introduction. So let me start by saying that I'm super happy to be here and to be the first one to share with you some experiences that I've had during the development of my career in several fields that tend to move always around this idea of measurement. At the end of the day, so we are very obsessed with causality, which is fine, etc. But one of my major claims is that we have not done our homework, let's say this way. So we have not done what our colleagues in the natural sciences did in the 19th century or in the 18th century, which was to start collecting bugs, classifying them, etc., etc. So what I'm going to present today is an attempt at showing you how I've done this for the task of policy portfolios. Okay, so what I'm going to cover today are basically three different things. The first one is an overview of what are these policy portfolios. And I'm going to show you both the possibilities that they have, but also the reality. So published work nowadays that shows how this works in the real life. Then I'm going to go for a brief tutorial if you want to know a little bit the techniques or the concrete implementation in an R package that exists nowadays. And then I'm going to share with you some ideas about where can we lead with this, where can we go. So new frontiers, and especially I'm going to touch upon a small experiment that I've been doing with large language models. Okay, so those are the three main tasks for today. What are they? An implementation and small notes about how can we develop this further. So the idea with policy portfolios is, at the end of the day, it's extremely simple. So it's basically try to see what has been done in public policy. So for lots of years, we have been simply measuring public policies in terms of money. So how many money this country devotes to child assistance, to unemployment, to, I don't know, climate change, to transportation, right? But that's not exactly, or that's not the whole story. So we want to know what is done and how it is done, right? So it's not only about the money, right? So the idea is to combine this, what is done, with how is it done, into what we call targets and instruments. Targets would be the kind of thing that you want to address. Where do you want to your public intervention to be? And how is using which kind of instrument. So the basic distinction would be between the carrots and the stick. So you want people to follow because you have a stick or because you have a carrot there. So I'm going to work all the presentation and in all this hour with this idea of targets and instruments. As an example, for instance, some of the work that we have been doing is on environmental policy. So air quality standards for carbon monoxide, that would be a typical target that some state, some government would want to focus on. Air quality standards for lead as well, carbon dioxide emissions for aviation activities, etc. But basically, you get the idea. It's just simply which kind of thing do you want to target. Of course, the second part is the instruments. And in this sense, usually the instruments are a smaller set of things to consider. In that case, we have obligatory standards, for instance, in the environmental portfolio, sometimes just simply prohibitions of bans of products, technological prescriptions, voluntary instruments, I don't know, public investments, etc., etc. So once we put together these targets and instruments in a two-dimensional space, we end up with this sort of figure. So we have targets on the horizontal space and instruments on the vertical space. And basically, the idea is, do we observe in this combination of vertical and horizontal space a public intervention? Yes or no? If we find a public intervention, then we cross this space and we just fill in the box and we say, yes, there is public intervention here. Or I don't know, no, there is no public intervention in another target and in another instrument. So at the end of the day, it's very simple. It's this dual space between targets and instruments and this yes or no binary answer. Some examples, for instance, are those two that we have here. So we have the 76 Italian portfolio and the 2018 portfolio with the overlapping values highlighted in black. So as we can see here, for instance, the Italian environmental portfolio grew a lot in 30 years. So it went from covering 5% of the total space, right, into covering 36% of the total space. So we move from one to the other. Other things that happen is that, for instance, these technological prescriptions that we see here were massively employed. But at the same time, tax or levies were not very much employed. So those are lots. Those can give you lots of ideas about what we are going to do. So just to put a little bit of numbers, we were covering 10 instruments here, 46 targets. So this was making us a complete potential space of 460 spaces of potential policy intervention. Of course, then you can start multiplying this. You can have, for instance, 23 countries. Then you can have different years. So this leads you to several different number of observations. So we would be observing these 460 spaces with more than 1,000 observations. So this is, I mean, it's a lot of raw and minor data, but I'll show you that it's not that complicated to deal with at the end. The nice properties that this idea of policy portfolios has is that it's a binary indicator. So it's just not a lot of complication there. It's simply asking the question whether there is public intervention in target T and instrument Y at time Y or T if you want exactly. Then you can also discuss whether, well, but the targets change over years or change over days. One could argue, well, that's no problem to deal with these kind of things. We can deal with discrete and continuous time with this idea of policy portfolios. And also another nice property is this exchangeability idea. The exchangeability means that basically all the space that we have here, we could change the position of one and into 30 and nothing would change. So this is nice because it allows us a lot of flexibility, although at the same time it gives us a little bit more complications to calculations. But it's also a very nice property that we have here. So I would like to sell you the product of this Swiss Army knife of comparative public policy, emphasizing the fact that we are able to compare across time. So if you are comparing money, well, is the money in 1970 is the same as the money in 90 or in 2020? Well, here it's just simply, do you have a policy in place? Yes or no? So you can very easily compare across time. You can also compare between units very easily. So it's not like, yeah, but they do less things with this money. No. We are just simply comparing always exactly the same set of things. Another nice advantage is that we can use it in different levels of government. So we can compare or we can map these policy portfolios for countries, which is what we have mostly done. But we can go to the regions, we can go to local entities, and we can also work with IOs. So what do they do exactly in the same logic? Then with these policy portfolios, with these boxes checked or not checked, it's possible to extract a lot of information. And that's what I'm going to show you in a minute. But basically, it's not only how much size it's addressed, but also which are the properties, how much is covered, is there diversity in the instruments that we are using, is there diversity in the targets that we are using, etc. And last but not least, let me emphasize again this idea that at the end of the day, it's a very simple low-level data collection, but because it's just simply asking lots of times, I know, but it's asking very simple questions. Is there public intervention in country, whatever, in this target and instrument for a specific moment in time? Yes or no, right? So the list of advantages is great. However, what are the possibilities then? What can we do with it? So in terms of measurement, I need to say that it's not challenging per se. So we don't need measurement models. We don't need complex or aggregations like averages, etc. But we need to use usually several different other disciplines to bring together things like. So what can we do? We can measure the size of policy intervention. How far has public intervention gone? How many boxes, let's say, are covered or are not covered? Which instruments are mostly covered or not? Which targets as well? And we can also measure burden I'll go back there in a minute. But it's just looking at whether we have a lot of black dots there or not. That would be the first idea, the size. But we can also measure diversity and try to learn about the patterns of public intervention. Do we find that public officials or the laws say that basically we are going to address lots of things, but using exactly the same instrument or not? Are we adapting our targets to different instruments? Can we? The idea here is the law of the hammer, right? So that when you have a hammer in your hand, everything is a nail. And one thing to distinguish is whether they are using different sets of tools to address different nails. So are their targets addressed using different instrument configurations or target instrument configurations, or just simply we know that we know how to ban things, so let's ban everything, even if we are addressing targets that are not specifically suited for bans, or they don't work very well in bans. So we have also lots of measures in this idea of policy portfolios. And finally, we can also compare similarity. So that would be a little bit putting together in different levels the different portfolios and seeing whether there is a correspondence between the spaces that different units cover. So for this, for instance, we have used some algorithms of image processing to see whether two images overlap or not. For the first one, for the size one, we were greatly inspired by biology and by ecology, especially trying to see whether we can find ecological diversity. So in our case, whether we were able to find other sets of diversity here. Just as an example, this would be the list of measures that in a simple function you can get from any of your portfolios. So space, size, instruments and targets, and the potential, the proportion of instruments and targets covered, for instances, then the equality and diversity, and then of course all these burden measures, which are basically size weighted by different things. So it's relatively easy to get all these kind of things. At the end of the day, how have we used this? I have here a link that you can easily access, and I think I have also included, if you can comment on that, but I think I have included it into the chat, the first thing that I did when I entered. So you can go there and just download any of them that you want. But as an example, I will show you that there are basically three different groups of contributions, scientific contributions. The first ones are let's say, the more abstract. So for instance, we just recently published on Nature a comparison of systematic databases on climate change policies, and we use this idea of policy portfolios. We use different databases, we put them together into this idea of policy portfolio, and then we were able to systematically compare them. Another set of papers that we have published with different colleagues are basically looking at policy growth and size. So whether there is a lot of policy intervention or not, what explains that, which kind of party families do favor more policy growth or less policy growth, whether some politicians, mention some areas a lot, but then they don't focus their intervention on those areas, etc., etc. And I would like also to raise your attention about another paper which diverges a lot. So it uses exactly the same data, etc., but now it's basically looking at diversity, not looking at size per se. So as you can see, there's a lot of literature that uses these approaches, mostly on the areas of social or environmental policies, and at the comparative level in terms of countries. For instance, the APSR, the recent one, was looking at implementation burden, right? So size. And here we can see whether in two different sectors of policy intervention, the environmental sector and the social sector, there was an increase in the number of policies, or in the size, or in the burden of those policies. For instance, in Austria, we would say that we went from almost no environmental policies in the 80s or in the early 80s to covering 1/3 of the potential spaces in the 20,000s. This is the raw data. And another option would be to look at diversity. So again, whether we are using this law of the hammer. So for instance, here we have the French portfolio with relatively low diversity. So they are covering very few targets, but also it's important to know that they are only covering using mostly one instrument and then two more instruments there. But mostly they are using only a single one. However, in 2005 in France, average instrument diversity has increased a lot in the sense that they are now using very diverse sets of instruments there. The same for the United States, although the United States in the early stages was also using a very diverse set of instruments. So those are the kind of things that we focus on. Another, for instance, that would be once we have these numbers for each one of the years, we can observe all these figures. For instance, the United States shows that their policies were quite diverse and quite sustained over time. Another example is the similarity, is this overlapping between different spaces. So what we have here is again a comparison between what happens into different targets of environmental protection and different instruments of environmental protection, and the distance between, let's say, the EU and the member states, right? So the darker the color, it means that more countries are covering a space, the same space. And the colors refer at whether the EU, a mandate from the EU, has really influenced this or not. So for instance, here in data collection and monitoring, which are at the bottom that we can see. So there's a lot of darker colors, which means that the EU was pushing a lot for this to happen in this sort of environments, right? Then, of course, once we have this graphical visualization of that, we can also do things like, okay, where was the EU driven, where the policies EU driven, where the policies state driven, and we can compare many different things by compiling data at different countries and at different years. If you allow me another example of this recent publication on a database comparison, let's imagine that you have this as the climate portfolio of Germany in 2005 and 2022. So that's basically asking, is Germany doing anything at all for climate change? And which would be the targets, of course, here. And which kind of instruments is Germany using to address several different issues? And once you do that for several different databases, then again, the databases don't imply that the targets and the instruments need to be exactly the same. You don't need that. But if you have this same structure, if you are able to convert all the information into this dual space, you are able to compare then how much of the size is covered. And what we found is that there's a little bit of divergence between what some databases cover and some others cover. So for instance, this would be the comparative, the climate policies database. This would be the European Energy Agency, the EIA, or the climate change laws of the world. And they all show an increase in climate policies again, but in a different way. Another way to compare them, of course, is to check point by point, dot by dot, country and year by country and year, which ones are more correlated and which ones are less. So at the end of the day, how does this work? And what I would like to share with you is this package, this policy portfolio that works in the following way. If I'm able to stop sharing here, maybe, and going to share something else. No, I'm not. Okay. No, let me. Whoops. Because let me show you. For instance, that's the typical spreadsheet in Excel, for instance, that you would have here. So we would be dealing with a sector that I just invented, artificial intelligence, for instance, in Senegal, and we are looking at 2025. So what is Senegal doing next year in artificial intelligence? Let's say that we agree that there are 5 potential targets that you can address in artificial intelligence. Then we would have them here in this column with the targets. And let's also agree, and for the sake of simplification, that we are using 3 different instruments. Like, I don't know, giving money to the private sector for developing new ideas, prohibiting AI to do some things, and I don't know, collaborating internationally with somebody else. Those can be also some sets of these ideas. So this portfolio would be then simply coded very simply as either zeros or ones, true or false. There is something, there is not anything. So for instance, we would find that target 1, instrument 1 in Senegal is covered by policy, but not target 1, instrument 2, etc., etc. Right? So this would look like something like this. So we would be able, with this package, to use this function ppplot, PolicyPortfolios plot, and get into the object that we just saw and see something like this. Target 1, instrument 1 is covered. Target 2 covers 2 instruments. Target 4 also covers now 3 instruments, the full set of instruments. And target 5 covers 2 instruments, but different ones. Then here we can also see lots of information that we can learn about this comparative policy. So for instance, div-AID, that would be the diversity. So Senegal is using quite a lot of diversity to address this toy example. So what we have here with the policy portfolio is a set of tools, a set of functions in R that allow you to clean, so you avoid making some mistakes with this large set of data. You can also complete, you can homogenize the sample. Sometimes you just forgot to add some target or not, but you can check. So there's a lot of care in this package to do a very good data collection. But also in a single function, pp measures, you can get all the measures of your several units of analysis, several years, several sectors, etc. All the measures that I was mentioning before, size, diversity, etc. Of course, another possibility is to very easily plot the portfolio, as I have shown you, and also to generate comprehensive reports. PP report, for instance, it's simply dumps everything into a nice PDF or HTML file where you can see lots of information about all your data collection, right? So that would be how it looks in Excel, and that would be how it looks in R. So you just simply load this library, you simply import your data, the one that I've shown you before, for example, the portfolios, which is basically this one over here, and then simply considering this as a policy portfolio, you just plot it and you generate the figure that I just shown you. And in R, it gets incorporated into something like this. That would be it. Another example would be like a toy example of other countries that we have there. For instance, the portfolio for energy that we invented, one, and PP measures would give you these tables in a tidy format in R that you can treat then very easily. And of course, the PP plot that I've just shown you right now. So beyond Beyond, we have several different ideas that are boiling our heads. The first one is convergence and intersectionality. Another one is whether we can try to enter into the kingdom of causality, whether we can use these policy portfolios to explain why some singular policy interventions work better than others. It's a challenge, but also we are doing it. And I'm going to focus right now into this experiment. Just as another way to represent data, for instance, this would be looking at hotspots in European environmental portfolio. So, for instance, in the red places, we would see that these two instruments are kind of hotspots in the sense that they are very much addressed. But those instruments and targets in blue means that those are spaces in which there is very, very, very few policy intervention, right? So you can do these kind of figures as well. The intersectionality, I'm not going to cover it because I want to go into this experiment that we did with large language models. So we predefined a set of 14 instruments and 73 targets in the climate sector. And we ended up with these 1,022 potential spaces of public interventions, right? So then we did something very easy that I wanted to show you before, but it was not possible. So you just simply can go to ChatGPT and ask ChatGPT something, right? So for instance, in my case, the realization was one day that my daughter was asking me about what is the function of the liver. And if you type what is the function of the liver, you get a reasonably good answer. You can put this into a little bit more challenging task and ask whether, I don't know, what is the GDP per capita of Germany? And I would say ChatGPT does a pretty good job of giving you facts, like the GDP per capita. If you try, you will have a reasonable amount of as a reply to maybe it's not exactly the official number, etc., but it knows some facts. So the question here is to ask whether in this experimental setup, we can ask ChatGPT using two different versions, using several different temperatures, using different prompts, and using multiple generations, whether we have similar results, right? What happens if we ask ChatGPT if Germany in 2020 had a policy covering a specific target and a specific sector, a specific target and a specific instrument, sorry. And you do that thousands of times for all of the specific spaces. And you also do that several times using different combinations, different language models, different temperatures, etc., etc. And I have good news and bad news, right? So good news, it's possible to do some things. Of course, the most expensive GPT-4 at that time and now the O1 are better and more secure. Prompts with more details are better. And it gives you much better results when focused on a single recent year. But at the same time, the results are quite bad. So if you compare them with what you observe using an army of coders, the results are not that good. For instance, one thing that was interesting was that LLMs understand temporal congruence. So if you ask them whether Germany had something in 1980 and something in 1981 and in 92, etc., ChatGPT doesn't give you noise in the sense that it doesn't give you, there were 3 policies and then we went to 1 and then we went to 5 and to 10. So it seems that there is a little bit of understanding of this temporal congruence that allows us to see that there is an increase in the policy portfolios. Another things that we were also doing was to compare whether in different countries, maybe also related to language, these large language models were able to help us codify the portfolios. And it seems that for some languages it goes better, or for some countries, I'm not sure whether it's language or not, it works better than in others. what was a big surprise is that LLMs are able to identify instruments. So what we are having here in this figure is the portfolio. So you have the instruments, as always, in the bottom, in the horizontal space, and the instruments in the vertical space. The black areas are what we really observe in reality. And the dots, the red dots, are how many experiments have found a policy there. So, for instance, there's a lot of negative false positives here, for instance, in this instrument, because ChatGPT tells us a lot of times that there is a policy everywhere, but using this specific instrument, right? So that's not really very good, but it seems that it has some clues as to whether different instruments are also possible. For instance, at the same time, it fails miserably with some targets. So we found really policies in this target, right? But ChatGPT found anything or didn't give us any concrete true positive in this space. So good news. There seems to be a footpath there. I'm afraid it's just a matter of time. So in a couple of months, in a couple of weeks, or in a couple of years, we would even be able to do that very with a lot of certainty. That's my impression. But again, not we don't have the crystal ball for how much are we going to incorporate this. But the good thing for me is that because we have this specific setup where it's very easy to ask very simple questions, that's the perfect setup also for large language models to tell you, yes, there is something, no, there is not anything, there is no policy intervention on that, right? So I've covered all the foundations, and I've shown you, I think, that a lot of things have been done, have been published in several different outlets. We have assessed not only that size, but also diversity and similarity in different contexts. I've also shown you multiple sectors like environmental, social, climate, etc. Although mostly all that has been done right now is at the country level, but also it's possible to compare that set. So I would like to have lots of opinions or other researchers working at the regional level, comparing levels, etc. But that's a very promising avenue here. So compare different levels because really the tool allows you to do that. At the same time, there's a lot to do. There is not anything that points towards an intensity. It's just simply, do you have something? Yes, no. And then you can have this size and other algorithms. But we don't cover the intensity of public intervention. We don't check whether, this policy, which is in place there, it's very much complied or not, or etc. We have not worked in different sectors, and maybe somebody, I'm working right now on the artificial intelligence sector, for instance, knowing whether some countries do have policies on that. But I think it's very promising because it can give us, as a discipline, the potential to work with different sectors using exactly the same set of tools in a comparative fashion, which is also something that I find lacking sometimes. A lot to do is also using these generative models, large language models, mostly to perform the low-level data collection. It's a possibility. I'm not a huge fan because it means that we would be relying on not collecting the data ourselves. And I think that part of the scientific endeavor is to go to the world and see really what happens, not to go to the world, which is ChatGPT, and ask ChatGPT, hey, by the way, do you think that there is something there? So it's a double-edged sword, but certainly LLMs right now can point us a little bit towards, hey, try to look there because most likely there is something, right? And of course, I'll be very happy to talk to you if you have ideas to improve the package or other uses, as crazy as they may sound, but most of it started with lots of crazy ideas anyway. So here we are, and I'll be very happy to have your input now, if you want.
Excellent. Let us remove the
Yes, I'm trying.
Participation screen, bring myself and Nir into the picture, and invite you to raise questions in the text, in the chat. But until you do it, let me start with the first question. Actually, let me thank you for the presentation. I think it's insightful and excellent, and we couldn't ask for more. I will do what we had mentioned before. This work was partly done originated in eBay, the Barcelona Institute of International Relations, and then Xavier moved to LMU, to Munich, working with the group of from Jacin Jordana, working with Jacin Jordana in eBay, to working with Christopher Neal and his group in LMU. Let me say that there was very, very small part of that years and years ago when we worked on diffusion, and I'm happy to see it. But let me go now for the question, okay? So we call it field goal. We did the field goal, and now for the question. How do you conceptualize targets and instruments, and to what extent the different targets or different definitions of targets and different definitions of instrument, or changing the place where they are being located on the space, on the two-dimensional space, can help us, or can change the analysis. So this is one question. The other question is, what would you say is the most theoretical important insight coming from this policy portfolio so far? So what was most exciting theoretically? Let's start with those two questions, give opportunity to others to raise questions, and then Neil will take over and you can read what's on the chat. So floor is yours.
Thank you, David. Let me see, because I have the chat in the other screen.
Yeah, the chat is for later. Start with my question and then with Neil's, if you want.
Good. The conceptualization of different instruments and targets. So there is, let's say that so far in Christoph's group, in Christoph Neal's group, we have done it using a lot of discussions and trying to agree at the end. But there's nothing really in this final way of thinking about policies in a policy portfolio way that tells us that we need to look for targets or instruments in a way or in another. So let me explain. So I don't know what is going to happen in the next 10 years in artificial intelligence, for instance. So I cannot predict which kind of targets will be filled or which kind of instruments states develop to address these targets. So the portfolio that I can do right now is probably very different from the portfolio that I can do in 10 years, right? So now I would be doing, I don't know, collecting data on several targets that maybe are just simply not used, and forgetting lots of targets that will open in the next years. What we have done, however, always has been to look back a lot of years. So we work mostly on the environmental sector. So the environmental sector was mature in the 70s in the United States, that's all, and then started to develop in all the countries. Because we got there at the end, we were able to see whether some combinations of targets or instruments were more or less likely, and we were able also to see whether we were looking at the specific places. I don't know, we look at CO2, at NO2, at lead, etc. But I cannot know, or I cannot predict whether in 5 years the environmental policy will be on I don't know, another compound that has not yet even been invented. So that's the answer, I'm afraid, is not very systematic, but it's simply that you need to scan what has been done everywhere and see whether you can also theoretically think that there are other possibilities, and that's all, and be able to change that definition or that set of targets eventually if some new policies or new things happen to later on.
Yeah.
So yes, it can change.
Going back to the targets, can you give us some example of targets? How do you?
Yes. For instance, at the very beginning, I shown you this list that we were having of targets in the environmental sector, which was, I don't know, let's address CO2 emissions in industrial plants. Let's address CO2 emissions in aviation. Let's address CO2 emissions from electric plants. All these kind of things would be
So it's
considered.
technologies. The targets are the technologies or the actors?
It's a combination of different things. In the case of the environmental sector, I would say it's a combination of technologies. But in the case of the social sector, for instance, is I don't know, do you have a policy for unemployment? Yes, no. Yeah, but do you have a policy for unemployment when I don't know, it's for younger people, for older people? Do you have a policy for on the social security for covering other things? So it's quite sector specific, and it can be chunked down to very small places. Yeah, I know, I want to know what happens to CO2 in power plants, or I want to know what happens to greenhouse gases in general. You can define your own set of specificity. That's not a problem.
Okay. And the other thing that I ask is, what is the theoretical value of this impressive work? So can you give us kind of new things that you could explain or argue with this visualization?
New, I would not call them new, but with this approach, you are able to do things in a different way. So again, we were coming from a world in which comparative policies are about, I don't know, at least in the social sector, it's very clear. How many money do you put on unemployment, right? And you don't care about whether it's for older or younger or etc. So it's just about money. Now we were able to take this into a new level and to compare how and specifically which kinds of spaces were covered, which is a little bit more addressed to how states react or how states also work. That would be one thing. So doing more precisely things that were done before. Other sorts of contributions in this line would be to theoretically understand what happens when you as a politician want to use your tool, your administration, to do new things, right? I mean, the temptation is always, hey, let's go and yeah, let's do more things, right? The theoretical contribution here is that we were able to quantify and to understand that this dynamic of increasing the number of or the spaces that the state wants to be there has also some drawbacks. Like, I don't know, if you don't include capacity also, so if you just simply tell your people, hey, we need to do 10 more things, but without adding or providing more capacity, it's harder. Just an example would be, I don't know, from one year to another year, your dean asks you, David, to give 4 more courses, right? So this would mean a lot more burden. but at the same time not providing you with more capacities. So we were able to understand this dynamic of relationship between capacities and obligations, especially in democratic societies where they are supposed to be reactive to the needs of the people. But if these needs start growing and growing and growing with no limit or attention for also providing capacities, we would end up with super complete portfolios in a very visual way, but also not effective or efficient or performant administration.
Got it. We will move to Nir if he wants, and then to Sachin. Sachin can decide if you read the text or he speaks, but Nir, you go first.
Okay, thank you, Xavier. It was exciting talk, and I would like to raise three issues or three questions. So first of all, regarding the portfolios themselves, so as mentioned before by David, they need to be grounded in analytical and conceptual frameworks. And my question is, for other projects, for different theoretical ambitions, perhaps just 2 dimensions, as you did with policy target and policy instrument, what might not be enough. Could you envision maybe a way to add more dimensions to the portfolio, perhaps portfolio with more dimensions, or maybe about the levels of the targets themselves? So not only about, for example, quality standards for lead, but also for the level of the standards. Could that something that might be achieved? So that's the first question. My second one is more about your way and your experience, both in the regulatory governance scholarship and the comparative public policy. So you've made considerable contributions in both fields. And my question is whether you would consider now maybe applying similar approach to your previous projects, such as the diffusion of agencies or independence. Could the portfolio work in other fields as well? And the third question is more about the future or forward-looking. So you have touched it, but even when we think about the field of regulation and future measurements for regulation, what do you think we need to go ahead? What are the challenges we have? What are new possibilities we have now with the language, with the large language models and so on? What do we need to be careful about?
Thank you, Nir.
And so on. Thank you.
Thank you.
Thank you, Nir. So these three questions, please don't ask me to add more dimensions. Don't ask me to add more dimensions because things start to get much complicated. But it's true that within this small set of two-dimensional spaces, we just simply have black, white. There is policy intervention, there is no policy intervention. Right now, what we are doing is to try to work with different degrees of stringency of these policies, right? It's another challenge because, I mean, technically you need to solve some things, but also empirically it needs a lot of complication. But that would be the new frontier. No more, I mean, I think that the idea with the portfolio is very easy. It's what do you address? How do you address it? Then stringency. You can decide whether to go for very low, medium scales, quantitative scales, whatever you want. That's also possible to do that. But I can only imagine advancing on this dimension. Can this work in agencies? Yes, and I've done some. So I'm not sure, but the figures that I've shown, this idea of two-dimensional spaces covering or not covering, are reminiscent of some videos that we have with David also covering whether some spaces of between countries and different sectors were covered by regulatory agencies. Although the idea is similar, it's not exactly the same. But clearly, there is the possibility to do things like, I don't know, we specifically for agencies are responsible for what? And in different countries, agencies are responsible for different things, right? So you can study, instead of countries, you can study institutions, as I've said, for instance, international organizations, and check whether the telecommunications agencies are covering the same space or not, etc. So that would also be possible to be adapted. And what do we need to be careful when using these large language models? I think it's there are two ideas here. One, I've mentioned it already. We need to be careful because if we are not the ones doing the data collection, who is going to feed these algorithms, right? So asking ChatGPT whether there is a policy there or not, I'm not sure it's the smartest way at the end as a scientist for us. If we outsource the data collection, I'm not sure that at the end it's very clever to do that. Of course, we can lower the barriers, we can lower the costs of getting this data, but we need to ensure some proper qualities. And to ensure that, we need to oversee these large language models. At the same time, for me, the biggest challenge in large language models is to make them understand what is a rule and what it is not. So we have lots of laws, for instance, and lots of regulations, but at the end of the day, what you want to measure is whether there is burden attached to 3 paragraphs or not. Because if a law is very large, but it only focuses on a specific subset of the society doing something once a year, that's one thing. But if you have a very small law asking the same subset of the society doing 3 things per year, that's a lot of burden there. So for me, what is important is to be able to ask and to be able to get a comparative assessment of whether in the field of regulation we can be able to say there is a rule here or there is not a rule here addressing. That's what I would like to have large language models for.
Thank you so much. So we have a question from Sachin. Let me read it.
Yes,
I can speak also if you want.
What's that?
I can speak if you want.
Okay, please, Sachin, come in.
Yeah, okay. So because I put the question earlier, but I think many answers were already given by Xavier. So thanks, Marin, for this presentation. I think it is very interesting. So my question that remains a little unanswered for me is, I've seen a lot of your work and even earlier work on measuring accountability and transparency and participation, or even when you say intensity, we have looked at Scaffrin's policy intensity scale. So why are we going back to binary measurements? I mean, is it like we are wanting the ChatGPT to be applied and which is more amenable for textual yes and no answers? Or is there any other reason why we want to stick to binary measurements? Yeah, that's my question.
Thank you, Sachin. I mean, the only reason, I mean, all this was invented far before ChatGPT and any large language model was barely usable. But the only reason is because, I mean, it's always a sacrifice. And the sacrifice that we are doing here is, hey, we want a tool, a Swiss Army tool that works well for lots of countries, that works well for lots of years, that works well for different sectors, and that works well for different levels of government. If we want something like this, we need to sacrifice stringency, sacrifice some other things. And the sacrifice is to do, hey, let's ask very simple questions so that are comparable across years, levels of government, units of analysis or countries, etc., etc. Because at the end, the results that you get is that, you know, I don't know, in Argentina, there is 3% of intervention. This 3% matters exactly whether it is one sector or another sector. And it's a measure that can be directly transferable to different levels, to different years, to different, etc. So the sacrifice is, let's go for the basics, very simple, but at the same time, gain a lot of comparability.
Okay, it's like depth versus getting the overview. Yeah. Okay, great. Thank you.
Welcome.
Nir, do you want to go? No? Or if not, I will ask the last question, and we'll stop here. So my last question to you is, can you repeat shortly what is the logic of the AI section of the presentation? What did you try to do there with the AI? And I might have another follow-up question, but go start with that.
Do you want me to share the screen again or the logic?
If you want, if you care. Yeah.
So let me go with the screen again, but also at the same time allow me to go for what is the logic. So it's, if you want, the logic is very stupid, right? So I just don't get me wrong, but at the end of the day, the question that, sorry, I need
We
to
see properties,
yes,
slide 13.
to go to the last ones, and it's taking a while to move. Now, no, now one. Yeah. So the logic is the following. I've been working with ERC funded research projects that imply a lot of money for data collection. Okay, imply a lot of money for assessing whether, I don't know, in a country that I cannot speak or even understand their alphabet, but I want to know whether in Japan there is a policy for CO2 emissions in plants, right? So I need to hire somebody there that goes there, downloads all the legislation, understands, etc., etc. Can we simply short-circuit this process and outsource it to a large language model? Why? Because it's simply, I mean, it's not a rational process. It's just simply going to the world and knowing whether there is something there or not. Instead of going to the world, I can also go to ChatGPT and ask for the GDP per capita. So if it gives me a reasonable answer for GDP per capita of Germany, can I push these large language models to ask me more concrete and specific questions that are very niche oriented, and with the idea that this will only get better, right? So if it is completely garbage right now, maybe we have some years in which we will still have to invest in a very large army of coders or people coding this. But if not, we need to understand whether it is possible to get these answers by simply clicking a button in our computer. When I was starting my studies, when I wanted to learn to know the GDP per capita of Germany, I had to go to a basement, get a CD-ROM, put it into a computer, etc. Later on, I was able to go to a web page.
Sure, I got it. So your answers, the conclusion is that AI give us reasonable reasons to be optimistic, that we don't need ERC in the future, or actually the LLM just digest all your publications so far and gave you the results.
Yes, that's why I'm saying that as a scientist, we have a responsibility to go and check for the data ourselves. Then there's the discussion whether as scientists also we want to teach the next generation of scientists to do data coding, because I started with data coding. If I'm short-circuiting the possibility of other people to start their research careers doing this because I can do it by ChatGPT, I'm not sure that the humanity is done in this sense, or as a species, we have the survival security. If scientists are simply not able now to get careers. So it's a double-edged sword, but we need to be sure. And the scientific curiosity is, hey, are we on the path to being able to do that using large language models? The answer is we are far from that, but there are some good reasons to think that it may be possible.
Excellent. It's excellent presentation, very exciting. I'm sure many people will watch it, and we will watch the series that Neil and myself are doing on the metric of regulation, and I'm sure we will invite you to take part in other initiative. Very exciting. Thank you very much, all of you, for your participation, and see you in the next webinar.
Perfect.
Bye.
Thank you very much.
Thank you.
Thank you.
Thank you. Bye-bye.